initialize Genesis sequence.
And we're live. Good morning, DevOps. How do you like the graphics? Yeah, I generated it using AI. I mean, I paid $20, right? So I thought I'd make some good use of it. So this is like my poor prompt got visualized this way, showing us some hunters trying to hunt some data or maybe gather the data. So that's the meaning behind this. Welcome to the talk, Hunting with Stream Gatherers. My name is Piotr Przybyl. I work as a developer advocate for Elastic, for search. If you fancy to follow me on social media, these are my whereabouts. I'm also Java champion and test containers champion. In fact, I'm quite like a little proud of myself because it's my first time as Java champion to this lovely conference. When I have time and I have something to write, I write to my personal blog post called softwaregarden.dev. The question is, who are you, lovely people? Okay, let's make it simple. Who's using Java 23 in production? Gotcha. Okay, 21. Nice. 17. Nice. 11. Okay, let's stop here. Who hasn't ever used a stream in Java? There are still people, very nice. So I will, because maybe you are not Java people, but we welcome people from other ecosystems as well. So I will, of course, try to explain what they are, just really, really quick. Little warning, right? He'll be dragons, caveat auditores. First, when I'm jet lagged, and I am, and I didn't have a good night's sleep because done fire alarm at a hotel in the middle of the night, and that means I can twist words, like put weird words into like a proper sentence. It's not Tourette's syndrome, but it's kind of like just high stress. So keep the talk with a grain of salt. Second thing. Stream gatherers in Java are still in preview, which means they can, in theory, change. They can even get revoked or basically removed, right? So if you're watching this, for example, with the Java 24, things might have changed, right? Keep that in mind. Yes. So for this thing that it's kind of like experimenting, I love when we software engineers put off some sort of like a scientific mindset and basically try to experiment with this stuff. So we'll be experimenting with this stuff. So this is not doctor's code, right? This is like a scientist's code. So we all keep like in mind what this session is about when you look at me. Fun fact, this session may be also about dad jokes. And fun fact, I mean, I have to share with it and marry you with me. So last week, I've learned this beautiful dad joke in Colorado. So question, how many ears did Captain Kirk have? You know, but you could like 3. Left ear, right ear, and the final front ear. It's that bad. Yes. Yes. Thank you. Normally, yes, I'm a bad joke connoisseur. So if you have any, please share. Sharing is caring. Yes. Little agenda. Normally, I don't do agenda. I don't like talking about talking. I guess it's better to just go talking, right? But I guess for this very talk, it actually makes sense. So there will be a prologue, then 3 parts: the why, the what, and the how, and we'll finish with a little epilogue, maybe even with some rants, right? So the prologue. Question: what happened 3,859 days ago? There were so many of you, but I have heard you. Okay, Carl, so you get the Polish jellies. He was the loudest, okay? And it's also like, he's like very, very close, so I can throw it safely. Sorry, folks, next time, sit closer. Yes, it was it. Java 8 was released. And what happened with Java 8 was lambdas, right? So we didn't need anymore to wrap stuff in anonymous classes, right? Create these classes on spot or anything. We could just pass in lambdas. So basically functions without any name, just identity, right, doing this stuff. And these were the cornerstone of streams. So streams are the way of processing data in Java. And unlike so-called reactive streams, they are not push-based, but pull-based. So when you create the whole stream, right, and it's almost ready until you call the, what's it called, the terminal operation, right, it's basically no op. And then it's doing as many pulls through the stream as it's dictated by the collect function to satisfy, right? So you might not process the whole stream. So keep that in mind. And how this stream looks like. So first it needs a source. Usually it's a collection, but you can create a split iterator. We might have like a generator when we have like a range of ints and we want to have random ints, right? Something like this. So we need to have a source. Then we have any number of intermediate operations. Basically we're doing something with the elements that are flowing sort of with this stream. And then we have terminal operation, just one terminal operation, unless you use a little trick, which I'll mention later. And these are the intermediate operations, I mean, not all of them, perhaps, that came with Java 8. So, of course, we have filter, map, and flatMap, sort of the most used ones. We can also use this, like change the primitives. We can look for distinct ones. We can sort them. Who's using peek in production? Maybe you should reconsider, okay? It's, I guess, I mean, unless you do it for like debug or like you really have to have this logging, it's okay. If you have any side effect operations, like please, pretty please don't, okay? Of course, we can turn them into parallel streams and so on and so on. And then we have a number of terminal operations. In theory, we could, I mean, just like in functional programming, we could have just one, like for example, reduce, right? So anything else could be implemented using reduce. So these others are like kind of like convenience methods, right? So they make our lives easier. And intermediate operations continued because after Java 8, Java 9 has happened, right? It was like quite a long gap, but nevertheless it happened. And we had two more operations, take while and drop while. So as long as the predicate was met, we were taking on dropping the elements from the stream, right? And Java 16, we had this map multi in some variants. And then the terminal operations also continued. And it had Java 16 a little debate, or actually before Java 16, where the two lists actually make sense or not, because you can have collectors to list or unmodifiable list, right? And with static import, it's not much a difference in terms of number of characters. Nevertheless, this is the extension we got. But actually, we got more. It's just they didn't appear in the stream API. Because in Java 9, we had two more collectors, filtering and flat mapping. And in Java 12, we had this team collector. Fun fact, I was discussing it during my very first talk at Devoxx Belgium, right? And what it can do for you is just when you have, like, for example, two collectors or maybe more, you can group them together just like the T command in Bash, right? So then you can basically feed your elements to two collectors, or you can get deeper. And in ecosystem, there are also like libraries emerge, like parallel collections, for example, by Grzegorz Piwowarek and his friend, right? So you can put your own thread pool to these collectors and they can run in parallel. These days, they also support virtual threads. And of course, like, who has this famous utils class or utils package in their? Yeah, I see like basically a bunch of hands. Yes, I mean, if you don't, your product is really, really tiny, I guess, or you're cheating. So here we go to the part, the first part, the why. Okay, let's go. Like we did a quick recap. Let's go how these streams worked. So these are actually sort of like the challenges. The challenges. Who speaks Polish? Yeah, exactly. Quite a few people possess this superpower. I'm sorry for you. So this is a count-out from Poland, or better said, from the southern part of Poland, right? The Krakow and surroundings, I was told. So basically, when children have to like select one of them, for example, who's going to be first to hide and seek, they can go like this: Ene, due, rike, fake, torba, borba, usma, smake, and so on and so forth and so on, right? So this is the stream of words we're going to use in the following examples, okay? I just split them by space, so we'll have a stream of words, okay? And the question is, how do you get only one word by length? Meaning, for example, I want to have only, oh, it's that guy, now I will have to smile. If I don't smile, they will AI me. Um, yes. Anyway, let's say I want to have just one word which has length of 3. So I want to have, for example, either due or ene or eus, right? Just one word. I won't have a word that has a length of 2 because there is no such word in this source, right? And so on. So and then for length of 4, I want to have rike or fake or usme, something like this, right? So this is how we can do that. Maybe I should go to code, right? Because we, the engineers in code, we trust. I mean, slides can take everything, right? I mean, especially if you're a manager or architect, but we, the engineers, I mean, so this is the stream, right? And this is the method, right? And this is what it's doing. Yes. So what I'm doing here, I'm creating a collector that's using this collector, and then going with this to map, right? So first, I have the key mapper. So my keys are going to be the length of the words, right? Then basically the value is going to be the word itself, and then if I already have, this is like existing word that I already have in a stream, and this is a new element. This is, by the way, new Java. This is how you ignore stuff. Yes, so I'm then choosing the existing one, and this is so-called finisher, so I have to turn the values into a hash set, right? Let me run this code. Sorry, not replace, run. I'm not a Mac fanboy, sorry. Yes, as you can see, we have one word of 4, one word of 1, one word of 3, and so on, right? So this is the business requirement, sort of. And then, as we know, if we need to reuse it, what we can do, we can wrap it into a collector. And maybe it's even easier to read in this form. So again, we have initializer, right, we have a finisher at the end, and so on and so on, like all these 3 or 4 parts, depending how many you need, right? Now, the business says we need to change the requirements. We need to do something else. We not just need to have one word per length, but we need these words to be all lowercase. Okay, so what do we do? Sounds like a perfect recruitment question, right? But it's like the bane of our existence. Yes, so we can do something like this. We can go and say collect, collectors, and then again, and here we use this unique length collector that we created in the past step, right? And then is this and then, right? So we need to do something else after collecting. So then I'm starting another stream. I'm mapping them to uppercase. I mean, they requested lowercase, but who cares, right? Yeah, you know how it works, exactly. And then we collect them to set again, right? So when it comes to, let's see if this code actually works as this. It should be with collect and up. So let's go here. Let's try to rerun it, which should be this shortcut. Yes. Almost done. I mean, almost done. I mean, it's uppercase, not lowercase. Yes, but as you can see, it works, right? And this is, so I can show it to you. I'm not cheating. Yes, this is the code, right? The thing is, my friends, maybe it's not the perfect code, right? It satisfies the business requirements, but we know that performance-wise, it's not optimal, right? We could map all the elements. Right? So before we create the stream, we can map. But then when we run the map, we'll map all the elements. And this might be a costly operation. So even if we're going to discard these words, I mean the second, third, and fourth word of the length of 4, we still need to map them, right? This is CPU cycles, time, and everything. So not perfect. Maybe we can do something like this, especially this is easy with records, right? So we could somewhat like create a wrapper class, so we wrap these strings inside, and we just change the equals method. So now these 2 wrapped strings would be equal if they have the same length. But then we create yet another type, yet another class, just to like sort of get the proper behavior, right? Or maybe we could have another pro and fancy solution, and I'm sure we could, right? And eventually probably we'll get back to the for loop and the good old imperative style instead of declarative streams, right? Or maybe what we can do is like if you maintain any library, any IDE, any framework, you know what I'm talking about, right? People come and say, and like, please add this stream distinct by, please, please, pretty please. It's because I have this legit use case. And it's true, they have this true need for this, right? So maybe the OpenJDK could add this distinct by. That's needed by a fraction of people, right? And have this like need is really like legit and justified. The thing is, we will then bloat the stream API. We will have like a gazillion or at least a dozen more methods, right? Used by a really tiny number or relatively tiny number of people. I mean, Java's huge, so if you take 1%, it's still like thousands of people. The thing is, if only there was something, and something that you could plug inside this middle of the stream, something that you could take it as a collector, right? And actually, this is the what we can do or what was done to address these needs instead of adding a dozen of these like distinct by methods and so on. Have you heard of a plugin? Exactly. Everyone has. So string gatherers are preview feature, or were preview feature in Java 22. Now they are preview feature in Java 23, right? And please don't hallucinate. So let me delve a little bit into, I mean, AI is a stuff apparently here, right? And this comes actually from the other talk of mine when I'm showing you how to make the thing not hallucinate, right? But this is it. I can say, what are stream gatherers in Java, right? And it says like stream gatherers in Java refer to blah, 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 and then you get stream collect. Yeah, exactly. So this is not exactly what we could have hoped for, right? So don't hallucinate this about this. So too long, didn't read the documentation or didn't have a time for a lovely chat with AI chat. This is it. We have a stream, and then you can toss any number of gather something operations, right? And then at the end, you can go and collect. In fact, you can do with this anything. You wouldn't need any other intermediate operation, any filter, any map, anything else. This is like a functionally, I dare to say, kind of like a superset of all that we have already and all that we requested, right? Or you can go, if you're more fancy into this functional style, into this and then. So what stream gatherers can do for us? They can transform elements so we can transform an element into another element, kind of like map works, right? But also we can transform one element into any arbitrary number of elements. This can be 2, this can be 17, this can be 0. Okay, this can't be -2, sorry. This is like a 0 or greater. You can then grab a number of elements and turn them into a one element of a different kind, right? And then actually this is the superset, right? We can take any number of elements and turn them into a different number of elements, like a different number of elements, right? They can track already processed elements, so they have something like a memory, right? They can suspend elements, so they can grab first, second, third, and then release whatever they want to release, for example, in a bulk after the first 3 were consumed. And they consume 1, 2, 3, and do something like, again, with this 3. They can short circuit, so they can turn infinite streams into finite streams. They can keep state between executions. I'm not sure this would be like how shall I put it mildly, the most appreciated use case, okay? But technically it's still doable, and they, of course, enable parallel execution just like for stream parallel. And then we go to part 3, the how. How does the darn thing work, actually? So let's try again what we did before, okay? Let me go to the code, because I guess it would be better. I'm afraid I'm good at annoying the camera operator. Sorry, operator. Yes, so let's go to this with gatherer. Okay, so how does it work is I can create now, I need to create, as you can see, gatherer here. So I'm creating it like in Spot, right, in C2. So this is the so-called initializer. This is the integrator. We'll get to that in a moment. No worries. And so I have my NS stream again. I gather the elements following my business needs, and I turn them into or collect them into an unmodifiable set. Or maybe this would be actually easier if we go to the with gatherers and up, so doing exactly what we're told to do from the beginning. So see, I have this NS stream, I have gather using unique by length gatherer, right? Then I map them to uppercase and collect them to a set. Okay, let me try to run this. Let's see if it works. Yes, our manual test is passed. Now, do you think this is somewhat more readable? Kind of like showing or making the intent more obvious, right? It's now staring back at you. And of course, like there are these two most difficult things in IT, right? Cache invalidation, naming things, and off-by-one errors. So this is the naming thing. Perhaps I could have named it even better, right? So yes, this is it. This is the unique by length gatherer, as you can see, and it has this initializer. So this initializes my state. And what I'm doing here, I check if my state contains the element I'm processing right now, and if not, then I add it to my the length of this element to my state. So I just add, for example, in this case, I have added 1, right? And then I push this element downstream. The code is available online, so I mean you can take pictures, but you don't have to. Yes, and then we can go. For example, we can make it fancier, something like this. We can go and say, "Oh, oopsies, I'm not super good at this." Yes, as you can see. Okay, something like this and this. I have to remove the element. Sorry. What I'm trying to show you here is we can go for something different. I don't always have to return true. I can say I'm interested in only first 3 words. Okay, so let me rerun the thing. And now, as you can see, it said skipping due, skipping fuck, and I have only ene, rike, and torba. Okay, this is the result, and this happened during the processing of it. So as you can see, I have like, I can't sing, so I won't sing, but I could sing. I have the power, right, of tuning how this actually works. Okay, back to the slides. So yes, this is this unique by length gatherer, right, which works like this. So as you can see, I hope you agree with me, this is now more readable. You don't have to wrap it, you don't have to go collecting and then it's sort of like decipher it, right, what it actually means. We can also create this, as I have shown you, this gatherer like on spot, right, if it's needed, and then basically this is the integrator, or even I could like include it here as a lambda, but then maybe it's not like the most readable piece of code again. So the formal definition, sort of like taken from the sources or the JEP, right? I recommend you read the JEP. JEP is the source of truth, but the source code is even better source of truth, right? It works like this. And now I can smell functional people working on this code, okay? Because I don't understand why we need to have T, A, and R, right? This is my hint for you. Fun fact, you can use the more characters, okay? Java is already known for its verbosity. You won't lose anything. And I dare to say, in this form, it's somewhat easier to reason about, okay? So we have the type of elements coming in, we have the type of the state, and we have the type of the elements going out. So gatherer can consist up to 4, needs up to 4 elements. 1 is always mandatory, the integrator, right? So the integrator is something that will take your state, your in and out elements, right? Supplier is responsible for supplying the initialized state, right? So that's why it's called initializer here. Combiner, if you run this thing in parallel, it combines 2 gatherers, right? And this finisher can push elements after you're done with processing, should you need to, right? And it can, as you can see, also investigate the state. So how can we construct these gatherers on site is like this. You go to off-sequential, just using an integrator, like I said. You can toss finisher, you can toss initializer, you can toss also integrator and finisher together, right? Or if you're not interested in just sequential thing, you can go with integrator and finisher, or all 4 of them, right? All 4 of these pieces, sorry, yes, like this. So the integrator is sort of the engine of this whole thing. It's unavoidable, right? So this is its signature, and what it does, it consumes the next element, right? and may or inspect or update the current state, like we did, right? We check that, did I already push like element of length n, all right? It can send any number of items to downstream, right? Not just one or not zero, any number. It can return true, and when it returns true, it means give me more. And when you, as you saw, when it's sometimes it can return false, which means I'm done with it. Don't bother me. Don't send me anything else, right? And it can also be greedy. Greedy is sort of like optimization. We have just this agreement between ourselves that it will never short circuit, right? Then we have combiner, which combines two parallelizable gatherers. Sorry, English is not my mother tongue. Then we have finisher, which can still operate on this downstream. I mean, send something extra, for example. And downstream basically is this kind of like a pipe to push things down, right? And we have some gatherers built in. I'm aware of 5. So there is fold, there's scan, there's window fixed, window sliding, and map concurrent. Fold and scan are for these functional people, and window are for these SQL people, right? Have you ever been recruited to any position requiring SQL and they had this window question? Okay, so maybe you didn't apply for the SQL position. Lucky you. Let's go for the built-in ones. That should be here. Let me just run this code, right? And as you can see here, for folding gatherer and for scanning gatherer, I have the same function, right? So the difference is here, fold and scan, right? Let me run it, and this is the result. See, so folding basically means it will, when I have the digits, right, from 0 to 9, it will create in just one element looking like this. When I have scanning, it will kind of like work as a prefixing one. So first I have 0, then because I had 0, I will add 1, then because this was my previous one, I will just add a 2, and so on, right? So this is how it works. Fixed, for window fixed, will like chop it into windows of fixed size. So I will have, the size of my window is 3, so I will have 3, 3, 3, and 1 at the very end, right? I mean the one element, which happens to be 9. And then I have window sliding, which is basically first 3, then I'm sliding by one element, and so on, and so on, and so on. So this explains you why this is the result we are seeing. So this is the first element, this is the last element, right? And yes, so this is it. Time for epilogue, right? I don't know why it's keeps showing this, sorry, this bloody bar. Who's using streams in production? We have seen. Who's using parallel streams in production? Okay, keep your hands, keep your hands. Who's using parallel streams in production in critical path? Yeah, people are like, okay, yeah, it's not me, yeah. Exactly. But you're using it. You're a brave man. Hey, you get jellies. Brave is a synonym of insane sometimes. Anyway. Yes, the thing is, if only these parallel streams could not block, because this is the thing, right? These parallel streams, they sort of block. So even when they're not doing anything, they're still blocking your or kind of like a pinning. This is the modern like word. The pinning like sort of the threat to your CPU core. And let me illustrate what I mean by this. So we can have something like, where is it? Here, I believe. Yes. So what we have here is this. I mean, please don't do that at home. This is just demo, right? This is for demo purposes. Okay. So I'm doing this. It's not even a benchmark. I know that Alexei Shipiliov is somewhere around, like, please don't summon him. I know this is not a benchmark, okay? So we just get the start time and stop time, and we're going to operate on 100 elements. And what we're going to do is we try to do in parallel stream, we're going to map them using slow to double. And I'm just using slow to double, which is doing possibly one of the most stupid things you can do in Java, which is thread sleep. Okay, even if, I mean, this is a no-no for production code, basically PR rejected, okay? If you use it for tests, I bet you don't, right? There are other ways, like a utility or stuff. Anyways, this is just like, let's assume this scenario, okay? Let's assume this scenario. You have like a list of invoices, and every invoice has a number, right? And now you have to call the payment system, right, to figure out if the invoice was paid, and if so, when. So you can do that in a loop, you can do that in batches, or in theory you can do that using streams, right? So basically what I want to basically have my list, or like my invoice IDs, or even my invoices. I want to make this round trip to the payment system, get the payment data, combine them, and like show our like accountants, for example, this lovely spreadsheet list, or even generate a CSV so they can see that in Excel, right? Kind of like this approach. So normally we wouldn't do that in streams or in parallel streams. Why? Because let me try to run this code. Question. If this takes 1 second, because fun fact, I spoiled it, right? It takes 1 second, and we have 100 elements. How long will running this method take? Someone said 10 seconds, and someone said? Yes, depending on the number of the cores of the machine, exactly. So you requested this information, sir, so I'm willing to share. This is my machine. Sort of 12 logical cores. So now, aided by this wisdom, right? When I have 12 cores, because we have like a real performance expert in the audience, right? So, if I have 12 cores, no, sure, like let's do this together. If I have 12 cores and this takes 1 second, how long will the whole thing take? Someone said 10 seconds. Can I get in more? Can I get in less? 8, 9. Who said 9? Okay, let's verify. Let's verify. Yes, let's verify if it's 9. And time for that joke? I don't think so. It's. I hope 9 seconds will pass even quicker. I hope this demo. Yes, it sort of took 9 seconds plus minus. This is like init time, like and stuff. Why 9 seconds? Because 100 divided by 12 is 8, and the rest of this is 4 elements. So it's actually 8 and 1/3, right? It's just it won't run for 1/3 of a second, so the 4 remaining tasks will still block 4 of my cores for 1 second, right? That's why I have to throw jellies. It was you, right? Okay, I throw you catch. Almost, yeah, very nice. Yeah, exactly. And of course, my CPU was idle, not doing anything else, and so on. So these questions are tricky, right? And now, if only there was something in modern Java that could allow us to do like this I/O round trips without blocking CPU, what could that be, friends? Virtual threads, exactly. Unfortunately, I couldn't even bring that many jellies, but I'm positively shocked that this is like the common answer. Virtual threads. Yes, virtual threads. So this, as we have seen, takes 9 seconds on my machine, right? And question, how long would it take to run both of them together? 18 or maybe even more. Yeah, it depends on like how many cores you have and so on, right? So you don't double the throughput, right? Or you don't increase the performance of your stuff by just copy and paste, okay? At least in this case. And then when you really hunt for this performance, there is this gem that came in Java 22. And I like it so much that first I have written a blog post about this thing, about gatherers map concurrent. Sorry, and then this is the post. And second thing, I annoyed Victor Klang on Twitter by mentioning this thing just once in the JEP. I think it's under-promoted, right? It should be on TikTok, basically. It is not. I don't know why. I'm not a TikTok person, but if you are, like make sure you put it on TikTok or Instagram or whatever you please. So. Because I think it's like really this gem, right? And this is like when the stars align and suddenly the things that were introduced in previous Java versions make your current life way, way easier. And let me show you what I mean by this. Instead of this parallel map, what I can do is basically this. I can go for gather and say gatherers map concurrent. And I can say I'm okay having up to 100 things happening at the same time. I mean, I can risk saying 100 virtual threads, and as you can see, it's the same method reference, right? So now, how long will it take to run this thing? Let's try to see. And 1 second it is. Okay, I'm cheating a little bit because thread.sleep is not blocking, right? And I'm showing it in my other talk, a bunch of virtual threads like a pro. But let's say if you have like really thin, it's not using lots of your CPU, and the heavy work is on the other system, and the other system can handle 100 things happening concurrently and stuff. You can turn it even up to 1 second or down to 1 second, right? That's why I think it's really under-promoted thing in these gatherers. With this approach, we can finally use sort of like parallel streams, only they are not parallel, they're concurrent now, right? To handle such things even in critical paths, right? And it's not exhausting this ForkJoin pool, right? Of course, if you don't get into like blocking issues and so on and so on. So handle with care and so on. So this is how you can use this thing with map concurrent, and of course we have to go back to this hallucination state. Thing, right, about the AI. So, fun fact, well, I asked you, like, and I possess this superpower, I speak Polish, but like, I even asked my German friend, like, if he knows what the square root of 81 is. He said no. Yes. It takes time, I know. But the fun fact is, to collect and to gather translates into the same word in Polish. Right? And then if you want to like use the common term for both of these things, gatherers and collectors, you're sort of like in trouble, right? So I'm insisting we should translate at least to Polish gatherers as zbieracze, because of this hunter-gatherer culture, right? Before we all became farmers. And I asked Victor yesterday, hey, why of all possible names have you used really this name that makes AI hallucinate? And he said, well, basically all other names like transformer and anything have already been used in so many places, right? Gather seems to be like underused, so we went for gatherer. So here is the reason. Still, if you think it should be renamed, I'm not nudging you, but maybe Victor is still around and you can like annoy him. Ask the architect session or something. Anyway, let me delve into more examples to show you when this thing can be used. Yes, so we have a few minutes left. Okay, so I have this gatherers demo. Okay, here. So let's go for. Now I'm going to use different set of words. So first I want to find palindromes. Fun fact: this was like why I did this palindrome, because I was doing this as my first programming 101 at university. It was to find palindromes, right? So I have this utils class. I just called it, or actually it turned into interface, and I just take a word, and if it's reversed, it's a palindrome if it's exactly the same word, right? It's like you know the sketch about that part by Monty Python, Ipswich, and yeah, it's okay. Anyway. Sorry, that was too far and too bad. I'm sorry of this. Anyway, I have a source of words, right? And it's not a fancy book. It's just this list. And I want to find words which are palindromes, like kayak or civic, right? So when when I run this thing, hopefully it will give me these words. Gather them for me. Yes. So this is how it can work, right? And then what I can do, for example, yes, I can use, so this is my gatherer, which I create like here on Spot, right? And inside, as you can see, I can do not only like filtering, but also I can do like replacing, so I get rid of any white space characters, right? That's why I have like this is like melted together in this gatherer, right? And then I have this filter to check if it's palindrome, and then I gather again this unique by length gatherer. So as you can see, I can go gather, filter, gather, right? I can get as many intermediate operations as I wish. Now, and this is funny thing, like going to this pairs. So I have this list of words, right? And I want to turn it into a list of pairs, right? And do I have the pair? Yes, I have a pair. Some people say that Java doesn't have tuples, like Scala, for example. I say, really? This is all you need to get like a tuple of 2, right? So I'm not sure if we need like any external library or anything. Anyway, when I run this thing, what it does, it's, as you can see, it turns me diamond and jacket and race car and cherry into pairs. So this becomes a pair, this becomes a pair, and so on and so on. So this is what I told you, that it can consume elements and then transform them and push any other arbitrary number, right? And the types don't have to match. So this is how you can transform. So maybe I would say transformer would be a better name, but as I've learned yesterday, it was already taken, right? And the number of these words isn't even, right? See, so radar is odd number. So now this is where you can see the finisher in action, right? So this is the finisher, and I check if my state, because what I'm doing here is like I check if my state is empty. If yes, and my state is, what is it? It's just an array list, right? So I add an element to my state, and then if it wasn't empty, I mean I had an element already in my list, right? Then I'm taking the first element. This is like addition from Java 21, so we can go for like get first, right? I can push it as a pair, so the previous element, current element, and then I can remove this first element from my state, from my internal state, right? And I can return true, meaning give me more, give me more, give me more, right? And then at the very end, when there are no more elements to process, I mean the radar made it to this state, right? Here I check if it's empty. If it's not, then I add an artificial element saying that this is a single one. I've learned sometimes that some time ago that in France you have these agencies that when you run a party and 13 guests show up, and 13 is really bad luck number in France, you can actually kind of like hire the 14th guest. So maybe I should have said 14th, right? In French. Anyway, yes. It's nice how we are all like the same and different at the same time. Anyway. Now we go for these length fluctuations. Let's say you are into monitoring or observability, right? And what you see as fluctuation is, for example, when temperature slowly raises up or slowly goes down, or the CPU consumption slowly goes up, and you have time for auto-scaling, and it slowly goes down, so you have time for downscaling and everything. Great success. Everything works as expected. But if you have this spike this way or that way, then it's a fluctuation and you want to know about this. So in this very example, what I'm doing is I'm doing this super dummy thing. I'm basically combining these words into a sliding window of 2 that will give me, as you can see, thanks to IntelliJ, a list. Now I have a stream of lists, and these lists are of 2 elements, first and second, which is also the last. I mean, because it's like just 2 elements. And then if I compare the length of the first element and the last element, and it differs more than 1, I think this is an anomaly. The temperature has risen like too sharply, sort of, right? So I want to be informed about this, and I just informed it to system out, because why not? I mean, this is demo only, right? So, oopsies. And see, so this is it. So when I have noon and redder, they differ by 2 characters, so that's why they made it here. I was alerted about this, right? But when I check the other words, for example, what else can we have? Music and cloud, you won't find them because they have 5 characters each, which means no fluctuation, right? So as you can see, you can use these gatherers, I mean the built-in ones and the ones you can create for many funny things. And now it's time for another bad joke. I was searching for a decent, like a real-life example to show you this. And what's the best thing for search? Of course, Elasticsearch, right? So Yes, it's bad. But I'm telling you, like I'm a bad joke connoisseur, right? Let me go. One of the reasons why Elasticsearch is so efficient at looking for stuff is that, fun fact, it can have so-called multi-valued fields. So it's not like in a SQL database when your field has only, or column has only one type. In Elasticsearch, your field, once you index it, can be expressed in many types. So it can be text and, for example, an N-gram. And what an N-gram is is something like that. How do I make this bigger? Like this. This is like an example tokenizer. Maybe I can show you here in the console, right? So when I go and analyze quick Fox in my just try to see how it works as an N-gram, this is what I get: a Q, QU, because the default parameters are 1 and 2. Here you can hear it with, and of course then you have IC standing for quick, just like we had here. And this is needed, like sometimes you wonder, I mean, there's like an e-commerce store or something, you type 2 random characters from the middle, and suddenly it shows you or highlights you like different words or different items they have in stock, right? So this is it. This is N-gram in action, right? And you can have it as, this thing, like let's say minimum length 3, maximum length 4, right? So then I have ABC, ABCD, and then I'm moving by 1 character. Sorry, you're looking from this way, and so on. So, I mean, there is, I guess, no need for you to rewrite Elasticsearch because it will soon be, I mean, the sources soon will be AGPL again with the next release. But let's go for this N-gram gatherer. Is it this? Yes. And maybe actually I should start because I was memed recently by a friend of mine. How should I show you this? I got memed by Andrzej that I love to run tests. A fun fact, I do, right? And as Dr. Venkat says, if there are no tests in the PR, I mean, the PR has to be improved, right? So maybe I should start with tests. Let's see if I have any. Yes, fortunately I do. And yes, so when the size differs by more than 1, then we throw, come on, wrong keys. How do I do this? Shift escape, yes. Then I throw an exception that the difference is more than 1, but when I have like 3 and 3, the N-grams I expect from this are the following: ABC, BCD, DE, CDE, right? Or when I have ABCD and I have shown you in the console, I expect these, right? ABC, ABCD, BCD, BCDE, CDE. Okay, so this is it. And let's make just sure this test is passing, right? So I'm not cheating. And fun fact, I also do like unit tests, not only integration tests, right? All tests are green, very nice. So we created this N-gram gatherer. It has this min gram and max gram, right? And this is the checks I'm doing. As you can see in constructors, constructor is a nice place to check all the invariants, right? And this is the initializer, my string builder, right? And then what I do is the following. I get this element, right? And I append this element to my state, which is my string builder. And this is just a single character, right? I assume I'm getting the characters out of this phrase I have to get, right? And then if the length is already like at least min, like I've reached, if it's A, B, C, D, E, I'm just adding A, I'm adding B, I'm adding C, and now I've reached 3. Right? So I emit A, B, C. And then I continue because it's true here. And then I add another element, which is D, okay? And then I check it's more than min gram, so I emit A, B, C, D. And then I check if it's this max position, right? Then I delete the first character, which is A in this case, and I emit B, C, D. And I push it again. So see, for this D character, if it's 3 and 4 in here, I'm actually emitting 2 elements. So in here, ABCD, and in here, BCD. And so the story goes, right? So as you can see, you could use it for something like this, like for actual business needs. And I don't know if you agree or not. I'm also added like a number of empty lines, but I think this is like a pretty neat way of like expressing such needs. Okay, now As usual, I tried to bring you, some stickers, right? So the stickers are here. You can grab as many as you wish. I'll be available till the end of day. The business day, and hopefully later as well. And now I have this request for you, not just for me, not just for DevOps, right? Just for every event. Please, please, pretty please share your feedback. You can even share your dad jokes, right? So please, always, everyone, always share your feedback. Use the DevOps app if you're okay with the DevOps app. Now, if you're watching this on YouTube, even like weeks or months ago, or even want to go for like free text entry, and you're really desperate to share these dad jokes with me, you can go for this anonymous form of mine. Okay, you can say what you liked, what you didn't like. You can say whatever. Just say hi. All right. Okay. This is me if you need to follow me on social media due to whatever reason. This is the slide with the slides and the link to code repository and everything. So if you want to follow it, show it to your friends, anybody else, this is the link. And with this, thank you very much. Bedankt und merci. Sorry, I need to take a picture. Do you fancy, like, how do you say cheese in your own language? You just say cheese, okay? In 3, 2, 1. What a lovely audience. Thank you very much.
All systems are nominal. Initialize Genesis sequence.